after noon on Sunday, so you can have it for your.
Actually, about for me, one of the problems that we were supposed to
No, ignore that part. Ignore that part. That's fine. That's fine.
also to tabulate the class results. And we
Yeah.
can
No, that is for a much bigger class. We can do that. Yeah. So forget about that part. You don't have to do that part. And then, so essentially, by Sunday you should have. Sunday night you should have all your material necessary to prepare your exam. So we'll do a review again next Tuesday, but it's going to be very similar to what we talked about last Tuesday. This past Tuesday. So we'll do it again. We'll have a short chapter, a quick chapter on team to get you some discussion going about teams before you participate in a lot of team projects. There actually will be quite some team project coming up in your study as you move through the 300 or 400 level classes. Especially capstone. Capstone, you are going to spend basically all your time in teamwork environment, so that is definitely going to help there. Any questions about our assignments so far, and question about the exam coming up? Cool. All right. So we'll pick up where we left last time. Just look at this very trivial example, but just give you a brief idea of what kind of thing we may run into in maintenance. So actually, it's hard for people to think about maintenance while they are busy doing their product that yet to launch a software system yet to be used by anybody. Certainly, as you get more experience and the team get more experience, the company become more experienced, this will become a requirement increasingly because you are getting more business. And if you don't think ahead of time, you're just not going to get it right. But very few people started with that mindset. I mean, for you guys to do that, it would be challenging, right? So I don't think many of you actually take maintenance into consideration when you are working on my project. Okay, maybe some of you did it, right? In this example, that say you have coded a software system for managing fruit sales, right? So when you were given that requirement at the beginning, you're only expected to deal with 7 kinds of fruits. Then, hey, that's all I need to worry about. So I'm just going to deal with this fixed set of data. However, later on, the software become useful, and people say, hey, why don't you? Our business is growing. We are selling many more kind of fruits. You need to take care of this, right? The manager and your owner of the business for selling fruit, their job is selling fruits, and they're not in software development in any kind. They will say, oh, just go at it. Then you go into the data structure and find out everything is hard-coded. No configuration at all. Basically, that entails you have to rewrite everything. Then the store owner say, hey, I can have it tomorrow, right? So essentially, they don't really understand the difficulty in terms of software engineering. They may overestimate the difficulty, or they may also underestimate the difficulty, right? So this is a very common thing to happen when people come to you and say, I need this new feature. I really want this new feature. Can I have it tomorrow? Right? Well, you have to really educate them. Well, this is probably not possible to get it tomorrow, but you have to give a realistic deadline. How long will it take? But essentially, at the design time or early on in the system, you may not have all the information you need to structure the system in an extensible way. So here is, the problem was actually caused by the original developer who might already move on to another great company, right? So for instance, the average length of time software developer in Bay Area stay on the job is less than 2 years. Okay, you have 3 years, 3 months, get settled in. You have 2 months, or even 3 months, looking for a new job. Basically, you are looking at this guy probably working on this software system is less than 1.5 years max. Okay, so with such quick turnaround of your staff, this is very common, right? So the person who is tasked to change the software system is not the same person who had worked on the software at the beginning, right? So in this case, basically you're fixing other people's code. So that's something that's a fact you have to accept now, okay? Yeah, so you may hold a grudge against the guy who did the software in a horrible way. You can make your curse or whatever, but you still need to fix the code, right? And you will deal with all kinds of things like no documentation, or make it worse, wrong documentation. So essentially, as we mentioned last time, more likely than not, you're just going to have the source code, the change requirement or bugs to fix. That's all you have. Okay? So however, if you are going to be on this job for some time, then you better make sure that you actually build in maintenance for yourself. And as a professional courtesy, since you don't enjoy working on a bad piece of code, you may want to create a good piece of code, a maintainable piece of code yourself, right? So that's why it's important to think about maintenance when you are actually constructing your system. This is not easy to come by. I mean, so to say for you guys, right now to take all these things into consideration, I mean, make sure that your software system is totally maintainable would be difficult. All right, and more, our development processes are more like agile processes, for instance, Scrum. Okay, which actually the philosophy is we only design for the features we know for sure at this moment. Okay, however, in that case, you are relying on very short increment, small increment to be nimble and agile, as the name says, to respond to changes and fix bugs. And a key part in all these development processes is actually refactoring. Refactoring basically say, hey, whenever we need, we'll change the system architecture. Okay, we'll change the system architecture, adapt to change, instead of trying to stick to the same architecture. Refactor our code. All right. So have a mindset for future maintenance will help you in any development process. All right. So let's look at what issue you may see. The first thing you may see, you are highly likely you're going to get this first, would be the defect report. This is when something wrong with the software system. Either the customer directly filed a report, or an application engineer working for your company, or your contractor filed a report. So you come back and say, hey, here is something wrong with the system. Okay? So ideally, that should have enough information for you to recreate the problem. But more likely, you're going to have to spend time even to reconstruct the problem. Okay, they may say, hey, they gave you a screenshot, right? This is going to happen a lot. You got a screenshot of your system behaving wrong. If they are nice, they'll give you. They'll have a description of the situation when they get into this screenshot, or they get even better if they give you their input. Then essentially you have to go recreate the problem. Okay, actually this is more difficult than you can imagine. All right, because the operating environment they have, your customer has, will be very different from yours. To be able to reliably reproduce defect is almost, I think, the first major challenge you have to tackle. Okay? So in the ideal case, every bug should be fixed. In practice, I mean, we don't do that. Okay? So we'll do an investigation of bug, basically to decide whether it's serious enough or not to fix now. Okay? So today, the bug that got fixed quickest would be the security bugs, right? Because you know security bugs are significant. Because if you don't fix them, they'll break in your computer, steal your secret. For us, I mean, we don't have much secret for them to steal. We lost our pictures, I mean, our images. That could cause you a problem, right? But I mean, nothing as serious. However, for other organizations, and particularly with money and secret involved, this will be a much bigger issue. So security bugs are basically the most serious bugs you can take care of. And also, if your bug is blocking your customer, those bugs will have higher priority. The other bugs, basically, you put them in the backlog and prioritize them, and they may get fixed in the next batch. That's why you don't receive bug fixes every day. You don't see patches every day. For any software, you will receive patches at most monthly, typically quarterly, and for half a year and yearly are also common. Right? However, if you sometimes we'll get say, okay, you need to patch it up right now, right? From Microsoft or Apple, they'll say you have to patch up right now. Those are serious security bugs. You better do it quickly. Otherwise, you will be very susceptible to security attacks. So for instance, last summer, when everybody was sleepy, right? So somehow the department wanted my student to move cubicles. They disconnected our network wires. Well, then we have to plug it back in. One computer that's supposed to be internal to our own group got put outside. It was compromised within an hour, right? I got a notification from CAT within a day. So they basically came into my lab and confiscated my computer and say, oh, we need to take a look at this computer, right? So that it's just, if you are not patching up certainly it's the internal computer, so we didn't really, we have an old version of software running on it, so we don't want to patch it up and mess it up. However, if you have made a mistake like plugging into the wrong port, you're in trouble, right? So in that sense, so if you have a security bug, so a security patch, you have to apply right away, pretty much. All right, so the maintenance programmer should first consult the defect reports. So defect report file, it contains all the reported defect not yet fixed and also suggestions for workarounds. This is very common in our practice, okay? Instead of you go fix a bug, you actually provide a workaround, which require no change to your code, but just a way to get around it. Okay, so this is probably make your customer happier, right? And also reduce the need for you to fix it right away. So you give this information to a user, and hopefully they can utilize your workaround. Then they can go about their own life without have to wait on you. If they have to wait on you, then that suddenly jack up the priority of the bug you're dealing with. Okay, this is the time if you are supporting software features, for instance, in all the major software company, if you are direct customer facing, you may got a call midnight and your manager say, hey, come, get up, we need to get it fixed right away. It's blocking our customer, or is a security reliability. We need to get it fixed. Then everybody has to get up and basically go get taken care of, right? So in that case, if you don't have workaround, safe workaround, then you pretty much have to get it fixed right away. All right. If a new defect, so the maintenance program should try to root cause the problem, come up with a proposal to fix it, and also possibly a way to work around the problem. Okay. This is actually got added to the defect report file together with all the supported documentation about all your fundings, designs, and menus, essentially for other people to look at it. So when other people see the same bug, they will know this has been detected before, and there's the workaround, or there's a schedule for this bug to be fixed. They can tell the customer. All right. So in this case, you are basically triage. This is called triaging. Basically, you are trying to find out, okay, what are the consequences of this bug? Should we fix it now? Is there a workaround that we can propose? And so put this in the backlog, right? So if it's urgent, if a security patch, you pretty much have to do it. Otherwise, you look at the overall priority and see and say, okay, when this will fit in. Okay. Then if you're in software development today, pretty much whenever you're going to plan for your next development cycle, maybe 2 weeks or a week or a month, you're going to look at the bug report file and say, hey, which set of bug we need to take care of first? Okay, basically a prioritized list. Right. So this file should contain information about client requests for perfective and adaptive maintenance as well. They enter the backlog as well, so so you will look at this and say, oh, hey, what do we need to fix and what do we need to add? All right. It's also important that this file got shared to all the developers in your organization, all the AEs, application engineers, which basically are people who work with the customer directly to make sure that their system runs and address their problem. So that the same feature, if occur at any other place, the user can determine if it's possible to work around the problem, or they know how long it will take, how long you will receive the patch. Okay? So how to prioritize the bug depending on who is your customer, what kind of software system you're dealing with, how serious is the problem, right? For instance, if say Mentor Graphics, they have a tool being utilized in Intel. If they get a call from Intel saying you need to fix it right now, pretty much you have to fix it, because Intel is typically their biggest customer, right? For your biggest customer, you have to provide bad service, pretty much, right? In that case, well, essentially you drop your work on the new features and fix this bug first, right? So this will create a lot of havoc in your development process when you are in the middle of your sprint, happily working on your new features, and suddenly you have to fix this bug. And fixing this bug will actually cause new problem with your new development. So that could be an issue, a recursive issue you have to deal with. All right. In the ideal world, we'll fix every defect immediately. Then we send out a new version, but that'll be inefficient, and also will be quite annoying for your customer. Just think about it. If you are required to restart your computer every day, that wouldn't be nice, right? If you're required to restart your computer every hour, that'll be even worse, right? So in that case, you actually you look at defect report first and see if you have a safe workaround. If you don't have the time to maintain the software, it's actually going to be batched in the next release. If you look at the Windows release schedule, or maybe we should use Apple, it's a better example. Every year, they will release a new operating system version, right? Every half a year, they will have a major patch. And every quarter, they have a patch, okay? Then you can update your computer. Basically, that includes all the security fixes and also functional problems and other things. So essentially, you batch them to improve your efficiency in fixing bugs. Because you cannot just interrupt your development team whenever there's a bug. That will basically reduce their efficiency to zero, okay? If you batch them up, consider a bunch of defects together, maybe that fixing one defect will actually take care of multiple defects, right? So that's also the benefit of batching everything. All right. The other thing you have to think about is how do you authorize a change to the product, right? So in terms of correctness maintenance, right? You assign a programmer to determine the fault and cause and then fix it. You test the fix, test the product as a whole. Remember regression test. That's how we actually keep the quality of the software system stable. Okay, regression test suite. Whenever you have created a unit test, system level test, even acceptance test, that should be in your regression test suite. Okay, so every time you make a change to improve your software or fix a bug, you rerun that test suite, which is called regression test suite. That is how we actually today, mainly how we make sure as we change our software system, we are not degrading the quality of software system much. Okay? If you don't do regression test, okay, you are going to break the product. Okay, that's going to be a major responsibility. So